Good morning. How are you doing? So today we're going to talk about quadratic functions, and you'll find that a lot of these things are things that we looked at in your previous grades. So that's nice. So we'll start off with some review. If you guys remember what's the vertex of this parabola, the vertex is the point where the parabola turns, and you find some people calling it the turning point of the parabola. So this is the vertex of the parabola, and for this one I think the x value is 2 and the y coordinate is 1. So the vertex is the turning point, or if it's a quadratic expression, it's either the lowest point or the highest point of the graph, the absolute maximum or the absolute minimum. What is the axis of symmetry of the parabola? The axis of symmetry will be the line that cuts the parabola in half. And for this graph, I hope you can see that that axis of symmetry is 3. Now notice that the axis of symmetry is 3, but also the x-coordinate of the vertex was 3. So that's something that we're going to build on. What are the zeros of the parabola? Zeros or solutions are points where the function, any function, crosses the x-axis or cuts the x-axis. So this function does not cut the x-axis. It doesn't cut the x-axis anywhere. If it cut the x-axis, if maybe its shape was like that, then these 2 points would be its zeros, that x value and that x value. But this one does not cut the x-axis, so therefore it does not have any zeros, right? It doesn't have a solution. So I'm just going to leave it blank. It doesn't cut the x-axis, doesn't have zeros, doesn't have a solution. What is the y-intercept of the parabola? That is the point where that parabola cuts the y-axis, and for this parabola that point is y is equal to 7. So the general form of a parabola or of a quadratic expression is f of x is equal to x squared plus bx plus c, where a, b, and c are all real numbers and a is not equal to 0. Because if a is equal to 0, then this becomes a linear expression, which is bx plus c, and it's no longer a quadratic expression or a parabola. So moving on, the general form of the expression, so a has to be, if a is greater than 0, so if it's a number that's bigger than 0, then the parabola opens upwards, or basically looks like that, looks like a U. And if it is a negative value, then the parabola opens downwards, or looks like that shape N. So we've seen that the axis of symmetry, we can talk a little bit more about the axis of symmetry of this parabola, and I'll come to this expression here in a bit. But I know you guys remember that from the quadratic formula, x is equal to negative b plus or minus b squared minus 4ac all divided by 2 of a. That is the quadratic expression. Now, on a quadratic expression, we know for sure, and you will find when you study a bit more mathematics, which you guys are going to do in both pre-calc and in calc, that for this expression, when b squared is equal to 4ac, or basically if what I have inside the square root sign is 0, what I have inside the square root sign is 0, then that equation, whatever the equation is, only has one solution, right? Then the equation has one solution or one root, or so if it is equal to 0, the expression, the equation, the parabola has one root, and in further mathematics it's called a repeated root. So you'll find that, but don't pay too much attention to this right now. So it has one root, and usually that root is the point where it cuts the x-axis. So if you find equations that satisfy this condition, a simple example I can give you is if x squared plus 4x plus 4. When you graph this equation, it will simply be, because if this is simplified, this is the same as x plus 2 squared, and if you were to graph y is equal to x plus 2 squared, it will be a graph that's shifted to the left 2 units and it's not moved up or down. So the point where it cuts the x-axis will be the same point where it turns, or will be the same point where it has a vertex. And interestingly, it's the same point where it has an axis of symmetry. So the general conclusion we can make from this, this whole everything that I've been saying, is that the point where the graph has a vertex, or the vertex of the graph, the axis of symmetry of the graph can be found at the point where this square root section of the quadratic formula is 0. And if the square root section of this whole quadratic formula is 0, then I'm only left with x is equal to negative b out of 2a, right? So that's all of this was just to get to this little guy. Negative b out of 2a is always going to be the axis of symmetry of your quadratic equation or of your parabola. So now, if I know that the axis of symmetry, which is right here, is given by negative b over 2a, then I can use that information to find the vertex of that quadratic expression, because if I substitute for the value of h in the expression of f, I should be able to get the vertex. What do I mean? So we have an equation here, and I want to graph it using its vertex and axis of symmetry, because I don't want to go all the way and draw the grid and put x and y and then plot one point by point. So if I want to sketch this one, the 2 points I need, one, axis of symmetry, which I know axis of symmetry, the x value is negative b out of 2a. So I go to my equation and ask myself, what is the value of a, what is the value of b, what is the value of c, by comparing it to the general form of the equation, of a quadratic equation. So according to this, I can see that b is 4, so negative 4, divided by 2 times a, which is 1. I hope you can see there's a 1 here, so that's the value of a. B is 4, and c is 3. So my value of x, the x value, the x coordinate of the vertex, or the x coordinate of the vertex, yes, or the axis of symmetry is negative 4 out of 2, which is negative 2. Now, going back to what I meant here on how to find the y value of the vertex, because if I have already found the axis of symmetry, it also doubles as the x value of the vertex. Again, taking you back a little bit, just hope you remember, I told you in this example that the vertex, which was the turning point, also is always the x value of the axis of symmetry. Alright, so going back forward, went through these things again. So we're back here. We have found the axis of symmetry, which is x is negative 2. Now all we need to do is find the y value of the vertex. So since we know the axis of symmetry is negative 2 and the vertex is the point negative 2 where that is the axis of symmetry and some y value, I know that if I substitute for this x value in the equation of the function, it should give me the y value of the vertex. So if I substitute for negative 2 squared plus 4 into negative 2 plus 3, substitute for that, I'm getting, this is 4 minus 8, that's negative 4, plus 3, that is negative 1. Yeah? Yes, negative 1. So my vertex is the point negative 2, negative 1. So vertex is negative 2, negative 1, right here. And at the same time, this is the axis of symmetry. So I know that the graph is cut in half at that point, and then I can just go ahead and sketch. 1, 4, 1. I know you're wondering, what are you counting, 1 and 4? I'm just counting based off of the general shape of the quadratic equation y equals x squared. This is not the label for this one, it's just the general shape. If it's the general shape, then you know this first point will be at 0, the next point will be at 1, 1, the next point will be at 2, 4, because it is squared, and the next point will be at 3, 9. So after I've figured out my vertex and axis of symmetry, I just count off of that point going either directions. So this is my parabola which has been sketched, x squared plus 4x plus 3. Alright, so yeah, this is what we did. We substituted for the x value of the line of symmetry, axis of symmetry, into the function, and then we found the y value of the vertex, and then we have our vertex, and then we are able to sketch it. We're going to sketch it here. 2, 3, 4. 1, 2, 3, 4. So that's what your sketch would look like. Alright, moving on to the standard form of a parabola. We have talked about the vertex, we've talked about the axis of symmetry. So the general form of a quadratic expression, remember, was f of x is equal to ax squared plus bx plus c. But we can write the equation in a way that immediately gives us the vertex and immediately gives us the axis of symmetry. Because if we write it like this, then we'll always have to do all the mathematics that we've done a couple minutes ago to find out the vertex and the axis of symmetry. But if it's written the way it is in this expression in the standard form, then we just read off the h value is the x value of the axis of symmetry, and the k value is the y value of the vertex. This is also still x value of the vertex. So that will give us the vertex right away. An example is here. I have this parabola. I need to graph it or sketch it. I know it's already written in the standard form of x minus h squared plus k. If I compare that to that, it's already written in the standard form, and I hope you can see that in place of h over here, in place of a, if I compare, a is negative 3, h, because negative h, this is negative h is equal to positive 2, that means h is equal to negative 2, and k is simply equal to 4. So I know that if I have those values, my vertex is going to be hk. So this means my vertex is negative 2, 4. My axis of symmetry is the x value of or h. So that's the x value of the vertex, which is negative 2. So I can go and sketch this one right away. The vertex is negative 2, 4. 1, 2, 1, 2, 3, 4. I hope you remember that this negative sign, because a is negative, the negative sign means that it is curving downwards. This is from a couple of screens ago. So I expect it to curve like this, downwards, to have that N shape. But I need to be specific about where what goes. I also hope you remember that this number is a vertical stretch, or a horizontal compression. So again, I would have just sketched this graph normally. I would have gone from here and know that 1, 1 would be here, and then 1, 1. If that 3 wasn't there, it would have just been like this. And the next point would have been here. Next point would have been here, because that's 4 units. 1, 2, 3, 4, and because this is 2 units, 1, 2. So, however, this value 3 stretches my graph vertically. So instead of 1 here, this number will be 3. It will be 3 units from this point, 1 unit to the on the x-axis. So instead of this point being here, it is instead going to be right here. Let me draw it in a different color. Instead of it being here, it's going to be here, because it is multiplied by 3. 1 times 3 is 3, so you got 3 units. And this point was 4, but it's multiplied by 3, which is now 12. So 5, 6, 7, 8, 9, 10, 11, 12, somewhere off the screen. This point is also 1, but remember, multiplied by 3. This point is also multiplied by 3 to get 12. So my graph, instead of having looked like what I have in red, instead of having looked like the red, you know, it's going to look like the blue. Please make your curve smoother than mine. Yeah, that's what your graph is going to look like. You can always check by graphing this on Desmos or on your graphing calculator. Moving on, find the vertex and axis of symmetry, then graph, or this is what we just did, and then graph. So that looked like that. This is not accurate, but you guys get the drift. So if I'm given an equation, can I rewrite the equation in general form and then in standard form? Remember, general form is ax squared plus bx plus c, and standard form is ax minus h squared plus k. So can you write that equation in either form? The answer is yes, you can. Okay. So in general form, I just need to rearrange this so that the x squared comes first, followed by the linear term, followed by the constant term, which looks exactly like this. In standard form, I need to complete the square. And I know you remember completing the square, so I won't go the very long way of completing the square. I'm going to show you a shortcut. I'm going to show you a shortcut. You have two options when you're finding the standard form. You can complete the squares. Now the shortcut, which is not really a shortcut, it is the exact same thing mathematically, but I call it shortcut so that it's more appealing. G of x. Probably shortcut because a couple of steps are left out. So what I want you to do is take the x value, because you know that this expression comes from the expansion of some square expression. So this came from the expansion of x minus 3 squared, because I know 3 is half of 6, that's why I have 3. I've maintained this sign, it's the same sign here. Now I need to subtract, because when I take the expansion of x minus 3 squared, I know in my mind that I will have an extra 9, because 3 squared is 9. Because, sidebar, because a minus b squared is a squared minus 2ab plus b squared. So if I expand x minus 3 squared, I will get x squared minus 6x plus 9. I am only interested in x squared minus 6x. I'm not interested in the 9. I'm interested in x squared minus 6x because that's what I had here, right? That's what I had there. The 13 is still there because it was part of my original equation. But I know that when I expand this, it's going to give me a 9, which is not part of the original expression. So to get rid of that 9, I know that I'll have to subtract 9. So this is why I call it a shortcut, because I take the x value, the x, I maintain the sign, subtract half of this value, so half of 6 is 3, and then when you close brackets and square, you still take off the square term of this number inside the bracket, because that would be an extra, and no one likes extras in the movies. So x minus 3 squared is what I end up with. Negative 9 plus 13 is 4. So I've written it in standard form. Now I can see that it looks like x minus h squared plus k, where the value of h is 3, and k is 4. The other option you can use is to find the vertex using the very first formula that we looked at, the very first approach, where you get to first find the axis of symmetry. And remember, the axis of symmetry is the value where x is equal to negative b out of 2a, which I explained the reason for this. So if it's rearranged, it's arranged according to the general format or the general formula, because it's x squared minus 6x plus 13. If I compare it with ax squared plus bx plus C, I hope you can see that A is 1, B is -6, and C is 3. So since I know that the x value of the axis of symmetry, or the axis of symmetry plainly, is going to be negative B, which is negative or -6, divided by 2 times 1, which is 6 divided by 2, which is 3. Is that the same thing we got here? Yes. Here our h value was 3, because if you compare this to this, negative h is equal to -3, h is 3, and our k value was 4. So our vertex was 3, 4. So from here, the x value of the axis of symmetry is 3. When I get this 3 and substitute it in this equation, it should give me the y value of the axis of symmetry. So the y value will be 3 squared minus 6 times 3 plus 13, and that is supposed to give us 4. Let's check. 3 squared is 9, 6 times 3 is 18, 9 minus 18 is -9, plus 13 is 4. So I still end up with getting my x value as 3 and y value as 4. I know that this x value is the h value, and I know that this is the k value. So I can just write my equation as y equals x minus h plus k, which is x minus h, which is 3 plus 4. So I have still written the same equation in vertex form, just like I did back here. So which method is easier for you? You decide and use that method. Alright, so the vertex, this is what I've just been going through, is located at that, and when I substitute this h value into the equation, this is what I just did. It gives you the y value. Right, an equation for this graph function. Check for the vertex. It's right here. This is -2, -3. Check if there is any shift in terms of stretches or compressions. So if the a value, because I know my equation is supposed to be ax minus h plus k, I already have the h and the k. Now I'm wondering whether I need to find an a or if it's just 1. So you check here. If the a is 1, then one movement to the right is supposed to be followed by one movement up, right? And then 2 movements to the right are supposed to be followed by 4 movements up. That is if a was 1. But I hope you can see that it's the opposite. 1 movement to the right is followed by half a movement on the y-axis. 2 movements on the x-axis are followed by 2 movements on the y-axis, which was supposed to be 4, by the way. It's supposed to be 4, but it's at 2. This one is supposed to be 1, but it's at half. So I hope you can see that in that case, the a value is going to be half. So my equation will be half of x minus h, which is -2, plus k, which is -3. I can write it as half x plus h, x plus 2, sorry, plus 3. No, minus 3. Minus 3. So that's your equation of that graph. Another one is here: determine the domain and range of this quadratic expression in example 4, the previous one. So the domain and the range, I hope you guys remember domain and range. These arrows tell you that the domain, or the x values, is -infinity to infinity, and the range, look at the lowest point of this graph, it doesn't go lower than -3, so the range is going to be -3 included all the way to positive infinity. Solve the equation over the complex numbers. So if I want to solve this equation, I can use the quadratic formula, I can use completing the squares, I can use anything that I want really. One thing I can't use is factorization, because there are no numbers that you multiply to get 1 and add to get 2. right? There are no factors of 2. This, I know we did UFO, those of you that get it, or if you just used factoring, there are no factors of 2. That there's no way you can multiply 1 and 2 to get 1, or add them to get 2. So yeah, factoring would not work for sure. Quadratic formula can work, and completing the squares can work. If I'm completing the square, for those that are interested, it would just be take x plus half of the coefficient of x, half of 1 is half, squared, subtract square of this number, which is 1/4, plus 2 equals 0. Very quick and efficient. X plus half squared, so negative 1/4 plus 2, negative 2/4 plus 2 is the same as positive 1 and 3/4, yes, 1.75, which is what's that as a fraction? Somebody help me. 7/4, which is 0. So if I am using completing the squares, this is half squared equals negative 7/4. Now that's where it gets interesting, because I have to solve for that expression. X plus half is equal to, I will need to take the square root of negative 7/4. Negative 7/4, and then that would give me x plus half, because I'm taking square root both sides. X plus half equals plus or minus, because I'm taking square root, root 7 divided by 2 I. Do you know why the I is there? Yes, because square root of negative 1 is a complex number. So I would just move the half to that side, and then my x will be negative half. Let me put it in front of this, plus or minus I root 7/2. So this would be my solution. Finished. If I want to use the quadratic formula, let me also use the quadratic formula. X squared plus x plus 2 is equal to 0. I need to compare it with ax squared plus bx plus c equals 0. Hope you can see that a is 1, b is also 1, and c is 2. So x is negative b plus minus b squared minus 4ac, all divided by 2a. Negative b plus minus b squared minus 4 times 1 times 2, all divided by 2 times 1. Negative 1 plus minus 1 squared is 1, 4 times 1 times 2 is 8, all divided by 2. Negative 1 plus minus square root of negative 7/2, and I end up with the same thing, because negative 1 plus minus square root of 7 is I root 7. Sorry, square root of negative 7 is I root 7 because of the negative over 2. If you want, you can write it as negative 1/2 plus or minus root 7/2. So, don't forget the I. So, which one is simpler for you is the one that you use. I personally prefer this one, but I know some people do not like it with a passion. So, go ahead and use the one that's simpler for you. So, question, what's the difference between finding the x-intercepts of an equation and finding the zeros of the same equation, or solving the equation? Well, think about that. You can pause and see your answer. See if you agree with this. It means the same thing, because finding the zeros are the x-intercept. So finding the zeros and finding the x-intercepts is the same thing. We have already solved this equation. Should have used a different example, but you've seen how this equation is solved. Another one is here. X into x minus 2 is equal to 10. If I expand it, x squared minus 2x is equal to 10. I like completing squares, so that's x minus 1 squared minus 1 equals 10, which is x minus 1 squared is equal to 11. Which gives me x minus 1 equals square root of 11. This is not, would have been a complex number if that was negative, but it's turning out to give me positive answers. So my answers will be, this is plus or minus, x equals plus or minus square root 11. Or I can use quadratic formula, x equals negative b plus minus b squared for ac, all divided by 2a. Substitute. I hope you can see that a is 1, b is negative 2, c is, if the 10 came over this way, c is negative 10. So negative of negative 2 plus or minus negative 2 squared minus 4 times 1 times negative 10 over 2 times 1. So negative of negative 2 is 2 plus minus negative 2 squared is 4. 4 times 10 is 40. 4 plus 40 is 44. So I have square root of 44, all divided by 2. Now this is 2 plus minus square root of 44. I hope you can simplify that to 2 root 11, all divided by 2. And at that stage, I can factor out a 2 into 1 plus root 11 divided by 2, and then I can cancel this 2 and end up with my answer as 1 plus root 11. Sorry, plus or minus. I know you've been shouting at me for forgetting to add the 1 from this side. I've also just remembered. Yeah, since this was x minus 1 is equal to that, if I want x alone, then the 1 goes over to the other side. 1 plus minus root 11. Yeah, this is your homework. Enjoy and have fun.